Welcome to another episode of AI 10X brought to you by 10 Leaves. For this deep dive, we are jumping straight into one of the world's most crucial transformation stories, fashion. It's an industry that, it defines culture and style, but it's also one of the biggest environmental culprits out there.
It really is. A massive consumer of resources and just. It has this terrible reputation for unbelievable waste.
It's this huge contradiction, isn't it?
It's the ultimate paradox. I mean, the figures are staggering. We're talking millions of tons of textiles ending up in landfills every single year.
And the water consumption alone.
Huge. It's a resource intensity that, simply isn't sustainable long term. But the sources we've compiled for today, they suggest a genuine path out of this.
And that's where AI comes in.
Right. Artificial intelligence isn't just offering these minor tweaks. It's fundamentally redesigning the industry, creating a kind of blueprint for sustainability from the soil up.
So that's our mission today. We're going to be your guides, diving into the source material to find the key mechanisms, those true nuggets of knowledge that show you how AI is actually achieving this.
And we see its role split into two really critical areas.
Two areas, okay.
First, innovating the very materials we wear, and second, optimizing the production processes and supply chains that bring those materials to you.
Okay, let's unpack that. When we talk about AI driving sustainability, we need to go beyond just the general idea of optimization.
Right. It's a bit of a buzzword.
It is. If the goal is truly radical systemic change, how is AI intervening at the most crucial pressure points?
Well, if we boil down the findings, AI's impact is, as you said, dual-pronged. It's working on the product itself, the fabric, and the entire life cycle of that product.
So it's not just one thing.
Not at all. Think of it as simultaneous attacks on waste generation and resource dependency. On the resource side, you've got AI enabling this rapid innovation in biomaterials.
Designing new fabrics, basically.
It's exactly low-impact fabrics. And then on the waste side, its power really lies in surgical prediction and supply chain efficiency.
How does it do that, though?
The ability of machine learning to just ingest these incredibly complex data sets and then iterate scenarios is what makes it so unique.
So it's pattern recognition on a massive scale.
It is. And it's allowing fashion companies to move from that physical, very slow trial and error approach,
Which creates so much waste in itself.
to rapid computational design. It saves years of R&D time and, like you said, mountains of wasted prototype material.
So we've got this structure for our deep dive then. We're looking at AI transforming the materials and AI transforming the manufacturing and logistics,
Creating better fibers.
and then making sure those fibers don't just become landfill fodder because of some inefficiency down the line.
Exactly.
Let's start with the materials because that is incredible. Our sources are really clear. AI is enabling innovation that is, and I'm quoting here, both stylish and sustainable.
And that's the key.
It is. It allows us to move past that traditional reliance on, high-impact materials like virgin polyester or conventionally grown cotton. What does this computationally driven design actually look like?
This is where we see a shift from, let's say, biology driven by nature to biology enhanced by algorithms.
Okay. Biology enhanced by algorithms.
I like that. The core technical mechanism here is often computational chemistry and generative design.
So instead of a scientist in a lab mixing things.
Exactly. Instead of a lab physically synthesizing and testing, say, 1,000 different molecular structures for a new biodegradable dye or fiber, an AI model runs millions of those iterations digitally.
Millions, wow.
The machine learning model can then predict, with really high accuracy, characteristics like tensile strength, dye uptake, how it drapes, and crucially,
And how it breaks down, its biodegradability rate.
right, and all of that before a single physical sample is ever produced. This just dramatically reduces the cost and time of material R&D.
Your shrinking development cycles.
From years to mere months.
That's the real aha moment here for me. It's not just automating an existing process. It's using predictive modeling to design a kind of new DNA for the cloth itself.
A new DNA, that's a perfect way to put it.
And we see these fantastic examples in the sources that really highlight this shift, like the development of lab-grown leather.
Absolutely. I mean, the environmental cost of traditional leather production, it's tied to cattle farming, land use, immense water consumption. It's just monumental.
So how does AI help there?
AI is helping to optimize the bioreactors that are used to grow collagen or fungal mycelium.
The biological building blocks?
The building blocks of these new materials, exactly. The AI monitors and adjusts the growth conditions, things like temperature, nutrients, acidity. It does this in real time to maximize the yield.
And to make sure the final product is consistent.
And that it has the desired properties. You want it to mimic or even exceed the quality of animal-derived leather. It makes sure that scaling up is actually possible without sacrificing performance.
And beyond just leather alternatives, the whole discussion around biodegradable textiles is so important. If we can design materials that reliably break down after their useful life, we genuinely start closing the loop.
We do.
So how does AI specifically make sure a textile is fully biodegradable without, compromising its wearability? You still need it to last.
It's a very delicate balance, which is exactly where these computational chemistry models excel. AI helps design specific molecular linkages
Okay.
that are stable during normal wear and washing, but are susceptible to breakdown, enzymatic or microbial breakdown under, say, industrial composting conditions.
So it's engineering for a specific end-of-life scenario.
Predictive end-of-life engineering. For instance, it can predict how including certain polymers will react to water or UV light over a 5-year life cycle.
And contrast that with how it will react to specific microbes in a compost facility.
Exactly. It moves material science from sort of guesswork to guarantee. And this ability to integrate end-of-life into the initial material design is just a fundamental pillar of this new sustainable fashion.
That's the product side, and intrinsically better fiber. But what happens once that perfect fiber leaves the computational lab?
Right.
The biggest environmental footprint of fashion often explodes in that chaotic, high-volume, inefficient manufacturing phase. How does AI bring that surgical accuracy there?
This is where AI tackles the sheer volume of waste caused by what are essentially business mistakes.
Overproduction.
Chronic overproduction. The traditional fashion model relies so heavily on, intuition and forecasting based on old data. The sources suggest that across the industry, companies routinely produce between 20 and 40% more items than they sell.
20 to 40%. And for you listening, we need to quantify that business pain, that unsold stock. It quickly becomes what's called dead stock.
Dead stock.
Material that just sits in warehouses, or even worse, is shipped straight to landfills or incinerated.
Yeah.
We're talking billions of dollars of resources wasted every year.
Precisely. So AI targets this waste through demand prediction with just unprecedented accuracy. Machine learning algorithms don't just look at last year's sales figures.
Which are lagging indicators. They tell you what already happened.
Exactly. They incorporate leading indicators, real-time social media sentiment, image recognition of trends on catwalks and streets, microclimate weather forecasts, local retail foot traffic.
All in real time.
All in real time. The system can predict not just that sweaters will sell in October, but specifically how many dark, navy-sized small sweaters are likely to sell in the New York metro area in the first week of November.
That level of granularity is the key.
It means inventory can be matched almost perfectly to market demand.
Okay, that hyper-accurate prediction is the critical intervention. It reduces the sheer volume of fabric entering the system in the first place. But I have to push back a bit on that idea. Doesn't this reliance on hyper-accurate prediction down to the color and size fundamentally reduce creativity? I mean, if we only produce what the data says will sell, are we just limiting the artistic, expressive nature of fashion?
That's a crucial point, and it reflects a real tension in the industry right now. But the sources, they indicate that AI doesn't so much dictate design as it dictates risk management and resource allocation.
So it's a guide, not a dictator.
Exactly.
Yeah.
Designers still innovate, but AI overlays sustainability and commercial feasibility constraints onto their initial sketches.
Can you give me an example?
Sure. A generative AI tool can integrate sustainability metrics right there in the design phase. It can immediately show the designer the projected carbon footprint or water usage of a specific textile or a certain colorway.
So it shifts creativity.
It shifts creativity to be focused on solutions within sustainable parameters rather than just limiting the options available.
That makes the process smarter, not just smaller. Okay, so once that accurate demand is established, how does AI optimize the physical movement of all this stuff, the notoriously complex supply chain?
This is the second pillar of operational efficiency. Logistics. AI is used to create these dynamic, optimized supply chain routes.
And the fashion chain is so complicated.
It's often multimodal. It involves ships, trains, trucks, and often really costly air freight. AI models analyze real-time capacities, geopolitical risks, material shelf life, everything to determine the fastest, lowest emission path for every roll of fabric,
For every single item.
for every finished garment. This means minimizing the use of high-emission transport, like air freight, and optimizing how containers are loaded to ensure every shipment is using its resources to the max.
And the result is a measurable reduction in emissions.
A demonstrable reduction in transportation emissions, and crucially, less time materials spent just sitting idle in warehouses, which is a major source of embedded energy waste.
It's fascinating how AI tackles both ends of this inefficiency spectrum. It designs better materials.
And then it ensures far less of those materials are wasted through overproduction or inefficient movement.
It elevates both the product and the process at the same time.
And if we connect these two transformations, sustainable design and logistical optimization, it leads us to the big conceptual outcome that's introduced in our sources.
Which is,
A fundamental shift toward what's defined as circular low-impact fashion.
that sounds like the holy grail for the industry, right? Moving entirely past the linear take, make, dispose system.
It is.
What exactly defines this new, highly automated model?
The key phrase running through all our source material is that this is a future where design, production, and consumption are all guided by data.
All three.
All three. It's about systemic change, ensuring materials stay in the economy and out of the trash.
You mentioned consumption. Historically, consumption was a black box, wasn't it? A purchase was the end of the data chain.
It was. But now, AI facilitates what's called reverse logistics. It can track garment usage, predict the optimal time for an item to be repaired or resold,
And even analyze the material composition of a returned garment to guide the most efficient recycling process.
Exactly.
The significance of having the consumption stage guided by data, you really can't overstate that. It means companies can design products knowing precisely how they will be recaptured and reused.
It turns clothing from a short-term consumable item into a reusable resource asset.
It fosters true circularity, where the supply chain actually loops back on itself.
It creates this constant feedback mechanism that continuously informs the design stage. If the data shows a certain biomaterial degrades too slowly, the AI model adjusts the chemistry for the next season.
If a distribution path is frequently jammed,
The logistics algorithm finds an alternative. It moves the entire industry from reacting to problems to proactively designing them out of existence.
this deep dive really clarifies that AI is proving that sustainability and high-quality design, style, they don't have to compete with each other.
No, in fact, the data-driven methodology is making both better, more predictable, and more efficient.
Which leads to a final, provocative thought for you to mull over, building on that concept of data-guided consumption.
If AI fundamentally changes our perception of clothing, from a consumable product to a reusable asset, how might that change the way you shop? Will our closets become more dynamic, informed by a system that prioritizes longevity and circularity rather than just being driven by fleeting trends or, impulse buys?
That's a fascinating question about the future relationship between us, the consumer, and our clothing, all driven by this invisible algorithmic hand. This was a deep dive into AI's role in sustainable fashion, brought to you by 10 Leaves.